Thanks for watching this 10th video in a series of work solutions for Edexcel GCSE Computer Science, helping you revise and prepare for Paper 1. So in this video we're going to go through how to get to the answers for question 3c, which is about file size and network transmission speed. And we're also going to introduce the keywords and concepts for RAM and ROM for question 4a. So remember, you can access this past paper through a link in the description underneath the video. And in the previous video we talked through the fact that we have a file that is 18 megabytes in size. We have a network that allows us to upload it at a speed of 2 megabits per second. And we need to work out how long it's going to take to upload this file. So if you actually worked out the answer, it would come to roughly 75 seconds, but you're not expected to work out that answer because it says construct an expression. So that just means we need one half of a formula here to give you how to work this out. So you don't actually need to know how many seconds it's going to take to download. So first of all, we need to understand what we mean by bits and bytes and mega and kilo and giga and all of that. So it helps to remember an acronym for this. We've got kilobytes, we've got megabytes, we've got gigabytes, terabytes, and petabytes. So I've heard some people talking about kick my granny to pieces. That sounds a bit too violent for me, so I prefer koalas make giraffes talk politely. You have to remember the order of these because kilo's the smallest, peta's the biggest. And if we're talking about size, as in file sizes, then we deal in powers of 1024 because that's the way that tends to be used in industry with hard disks and solid state drives and things like that, because 1024 is a power of 2. Kilo is 1024, sorry, 1 kilobyte is 1024 bytes, 1 megabyte is 1024 kilobytes, 1 gigabyte is 1024 megabytes, 1 terabyte is 1024 gigabytes, and 1 petabyte is 1024 terabytes. But rather confusingly in Edexcel exam board, if you're dealing with speed, then the industry doesn't talk about 1024, powers of 1024. If we're measuring speed, it's more like what we do in science, where we just deal in powers of 1000 instead. So if we're talking about bits per second, kilobits per second means 1000 bits per second. 1 megabit per second means 1000 kilobits per second. 1 gigabit per second means 1000 megabits per second, and you get the idea. So if you've got a measurement in terabits per second, then you have to do 1000 to get to kilo, 1000 to get to mega, 1000 to get to giga, and 1000 to get to tera. Okay, let's work through what that looks like. So first of all, we need to know how many bits there are in this 18 megabyte file. So we know there's 18 megabytes. We know that each megabyte is a quantity of size. So we're dealing in 1024, not 1000. So 1024 will get to kilobytes. We want megabytes, so we're going to times by 1024 again. That gives you the total number of bytes, but we want to work out the total number of bits, and there are 8 bits in every byte. So that means 1 byte is split up into 8 zeros or ones, so it can store a number between 0 and 256. 8 bits in 1 byte. Okay, then if you want to work out how many seconds, you need to take the total number of bits, which we've calculated from 18 megabytes, and divide all of that by your total speed. So we've got 2 megabits per second. Remember, bits per second is speed, so we're dealing with powers of 1000. So we've got 2 of these megabits per second. What is a megabit per second? Well, koalas make giraffes talk politely. M means that we have to go through K first. So 2 megabits per second means 2 times 1000 to get to K, times 1000 again to get to M, and then that gives us your total speed. So if we look at what gives you the marks here, we get 1 mark for doing 18 times 1024 squared. So we could have written this 1024 squared, that's the same as 1024 times 1024. And that gives you the total number of bytes. You get a second mark for multiplying that by 8 to get the total number of bits. You get another mark for saying the total number of bits per second is 2 times 1,000 times 1,000 for 2 megabits per second. And then the final 2 marks are just for making sure that you do the right value divided by the right value. So if you get the total number of bits and you put that at the top of your division, your fraction, you get 1 mark. And if you get your total speed and put that at the bottom of your fraction, you get the 5th mark. So notice you don't have to work this out. It doesn't say calculate, it says construct an expression. An expression is just one side of a formula. So one side of something with an equal sign. Okay, so the key things to remember here are koalas make giraffes talk politely, or kilo, mega, giga, tera and peta. That if we're dealing with quantity, as in size, bytes, then we do in powers of 1024. But if we're dealing with speeds, then we're talking about powers of 1,000. In this question paper and in the most recent exam paper, thankfully Edexcel did make that clear on their exam, but it's worth remembering it just in case. So there's one more question in this video that we need to go through the answers for. So 1 mark question here. Help. Thank you. You only need to write 1 of these in order to get your marks. So the question said, state 1 reason why the actual time might be a little bit longer than the time we calculated above. So you didn't need to work out that it would take 75 seconds. You just needed this expression here. But it's likely to take a little bit longer for any one of these reasons. So first of all, the network could be congested due to lots of traffic. Think driving during rush hour, it takes a lot longer because there's more traffic. It's the same on a network. We've got a bottleneck somewhere else on the network. So think of a bottleneck like, I don't know, someone irritating has put 2 chairs on either side of the corridor as you're walking from lesson to lesson. It's going to take longer to walk past that bottleneck, that small part of the corridor. And it's the same on a network. If one wire or one part of the connection between you and your server that you're talking to is slow, the whole network connection is slow. The server might be busy, so you might have the fastest internet connection, the fastest broadband connection, but if you're trying to upload to Facebook and the Facebook servers are overwhelmed and slow, then your connection to the Facebook servers is going to be slow. This says overhead of routing packets across the network. So overhead means additional task. Routing means finding out which direction to go. So think of this like a year 7 taking longer to go from one side of the school than a year 11, because the year 11 knows where to go and the year 7 has to look at a map or ask someone else. If you have to work out which direction to send your traffic across a network, it might take a little bit longer to send. Then we've got collisions require packets to be resent. So if a collision means multiple computers are sending data at the same time and that data gets corrupted, so it has to be sent again. And then finally, you could have said bandwidth shared with other traffic. That might mean if you're trying to upload at the same time as, I don't know, your parents trying to watch something on Netflix, then your bandwidth is shared. It's going to be slow. So any one of these for your marks. And then this video also, we're going to go through the keywords and concepts for 4a, so that you know what to revise to get ready for these. So all computers have a central processing unit, memory and storage. RAM and cache are both types of memory, and we need to describe one similarity, one thing that they've got in common between cache and RAM. 2 marks available here, so we need to state and describe. And then we've also needed to describe one difference between cache and RAM. Okay, so I'd recommend you have a look at the keyword activities for cache and RAM. There's a link in the description underneath this video so you can remind yourself what they are. You need to write down one thing that they've got in common and one thing that is different between the two. Okay, thanks for watching. I hope it's been helpful. In the next video, we'll go through how to get to the answers to 4 Part A.